the number of red balls are how many? 3. The number of black are how many? Now this is your total sample or number of elements are how many? 8. Okay. So this is your value of n of s. So let us look at the first bit now. What he is asking? He is asking that, okay, these are the balls which are available in a bag. Okay, you need to remove one ball out of it randomly. Okay, so what is the probability of the first bet? I think it needs to be a red ball only. So the requirement is n of r is equals to how much? The number of red balls are available are 3. The overall sample element is how much? 8. So the required probability of getting the required probability of an event, that is getting a red ball, is equivalent to n of e by n of s. Your n of e is your n of r now. So this is your 3 by 8 as your required answer. Hope this is clear to everyone, right? I can write this one as n of e also. Hope this is clear. So let us look at the second bit. The second bit is, this is not need to be a red ball here, right? So in the earlier sum here, we were having the probability of e is equal to how much? 3 by 8. We know the formula like this, isn't that? Equal to how much? 1. I'm substituting this one here, 3 by 8 plus probability of not a red one is 1. I'm shifting this one to the LHS so that the probability of E bar equals to 1 minus 3 by 8, and just solving this one with the denominator required. So this is your required result. So overall result is how much? I by 8, which is your red, white and not a green ball. Okay, so let me write it as overall sample element. Sample element is n of s. How many are given here? Red. Okay, so I need to write this in an order. So let me write it like this. N of red are how many? 5. N of white are how many? N of white are 8. Now n of green are how many? Only 4. That is your total sample. This is your total sample or total number of events which may occur. So this, if you are adding this one, this is your 12, and for this your hand side, that is your 17. Hope I am right up to here without any issues. So let us do the first bit now. Probability of getting a red marble is your n of e, that is under here n of r by your n of s. N of r is how much? 5 by 17. Hope this is clear to everyone, right? So let us look at the second bit. The second one is white. So the probability of getting a white marble, or let's say ball, is n of w is your required white by your total number of samples, that is 8 by 17. Hope this is also clear to everyone. So let us look at the third bit. That is, it should not be your green. Okay, so what I will over here is probability of getting a red plus white. This is clear. So that is, I'm just need to add here probability of n of r plus probability of n of w by n of s, isn't it? So n of r is how much? It's only 5, and w is how much? 8. That is your 17. So the overall last result is your 13 by 17. Hope this is also clear to everyone. Okay, number of 100 rupees coins. Let me write it here. Number of let me write 50 paisa coins. How many are there? 100 are there. Okay, good. Very, very good. And you are having 50 D1 coins, right? What is your D1, D2 coins, and D5 coins? Okay, let us look at this one. 50 number of D1 points are how many? These are 50. Okay. Now the next sentence is number of D2 points is how many? There are 20. And the number of D5 coins are how many? D5 coins are only 10. Right. Okay. Isn't it? It's the last one, right? Likely that one coin fall out of a bank is turned upside down. Okay. Let's see how do we solve this one here. Okay. So let me write that total number of points. Total number of points. Now you need to add up all this. See how do I do that? This is your 30, 80, 280, 180. So this is clear to everyone, right? So this is your n of s, right? Okay, let us do the first bit now. What will be a 50 paisa coin probability? That is asking the probability of 50 paisa coin if it is removed out or fallen down, right? Yeah, so that would be the number of 50 MPR. How many? Let me write is your required event is how many 50 MPR? 100, isn't it? It's your 100. Now, therefore, the probability of getting your 50 MP is n of e by n of s. This is nothing but 100 by 180. If you're solving this, 0 comes out. And this is your last answer, right? So let us look at the second bit also. Will not be a D5 coin. Okay. He is asking will not be a D5 coin here, right? And only so this is your number of events. The probability of E of D5 is how much? N by 180. If you're solving this, the probability of this one is 1 by 18. But what he is asking not. That is, he is asking E bar is equivalent to how much. So we have a formula, and you all know the formula like this is equivalent to how much? 1. So this can be written as 1 by 18 plus probability of E bar equals to this much. I'm shifting this one to the other side, so that the resultant would become it as to be equivalent to 1 minus 1 by 18. So this is clear. I'm removing I'm just following this one. So I'll get 18 minus 1 by 18. So overall the probability of E bar is equals to 17 by 18. Hope this is also clear to everyone. No doubt, right? Very good. Let's move ahead. Okay, let's see this one here. Go up for his aquarium. Okay, he's having some sort of aquarium. Good. He's aquarium. Okay. The shopkeeper takes out one fish at a random from a tank having 5 male udda. There's no diagram here. Skip the diagram. Okay. So how many male you are having? Let me write this data. Male fishes are how many? Only 5. And what about your female fishes are how many? 8. Hope this is clear, right? What is the probability that the fish taken out is a male fish? Okay, let us remove the total sample elements. N of s is equals to n of male plus female fishes. So this is clear to everyone, right? Female fishes. Now when I am writing this one, I am getting 5 plus 8. So when I write this one, the resultant is n of 13. That is, see, this is not n of 13. Okay, is this your n of s? So this is clear to everyone, right? Now he is asking that taken out is a male fish. So the probability of a male fish. Okay, that is your n of e. So if you look at the n of e, how many n of e are there? Only 5. Right? N of s is the number of elements, that is your 13. So the answer is how much? 5 by 13. Hope this is clear to everyone, right? Good. Likely outcomes, as you have seen in the first exercise, it is your 50 to 50 answers. Hope this is clear to everyone. What is the probability of that? It pointed at E. Okay, let us look at the first one. So the required sample element, that is your required event, is how many? 8. 8 is only 1. So the number of elements are how many? 8. So the probability of this event is how much? 1 by 8 only, simple. So let us look at the second one. The required event needs to be an odd number from the set. These are the odd numbers if I am not wrong. Similarly, the overall set is having 8 elements. The probability of this element is how much? 1, 2, 3, 4, 4 by 8. So that is how much probability of E is 1 by 2. Probably is also clear. So let me look at the third one. A number greater than 2. So in this is said the numbers greater than 2 are all these numbers, isn't it? So the required event is how much? 1, 2, 3, 4, 5, 6, right? 6. So overall here the probability of this event is 6 by 8. So if you're solving this, half of your numerator is 6 and half of your denominator is this one. Hope this is also clear. So let us look at the fourth one. Now he is asking you the number should be less than 9. So from this given set of numbers, these are the numbers less than your 9. If you look at the overall numbers are 8. So therefore the probability of this one is 8 by what? 8 by how many numbers are there? 8. Hence I can say that the probability of the occurrence of this event is 1. Hope this is also clear up to here. And from a well shuffled deck of this cards. Okay. So this itself is your N of S. First total sample, that's your N of S. Okay. Now find the probability of getting the first bit. So the required event is your N of E is what? Number of red colored kings. Number of red colored, and let me say red kings. Okay. So in this deck we will be having only 2 such cards. Okay. So N of E is your this one equals to 2. So the required probability is 2 by 52 as your answer. So if you are dividing this one out, the resultant is 1 by 26. Hope this is clear, right? So let us look at the second. But if you are looking at the second bit here, now he is asking here a face card here, right? See this face card. So that is your required event N of E. N of E is your face card. So the set is a king, a queen, and a jack, isn't it? So you are having 3 like that. So 3. See, this 52 is divided into 4 equal parts. Okay. Here you will be having it, 3 you will be having it, 3 you will be having it, 3 you will be having it. Means in each set you will have a king, you will have a queen, you have a jack as well. Okay, that's your joker. Okay. So I need to do here into 4. So this is how much? This is your 12, right? So the required probability is N of E is a required event 12. The number is how much? 52. So when we are divide this into fourth table, you will be having 3 different ratios, right? So the resultant is how much? 6. Okay. So therefore I can write here the probability of A is 6 by what? 52. Okay. So if you want to divide this, half of 6 is 3, half of 52 is 26. Hope this is clear, right? So let us look at the fourth bit. Let me write the fourth one here somewhere. Yeah. The jack of hearts. You require what? The jack of hearts. In hearts, the hearts you will be having only 13 hearts, right? Out of this one is your jack. So N of E is what? 1. So the required probability comes out to be 1 by 2. So this is clear to everyone. So let us look at the fifth number. Now you require a spade. So the number of spade cards are how many? These are 13. Okay. So therefore the required probability is what? It is 13 by 50. Hope this is also clear to everyone. If you divide this one, the resultant is 13 ones are 13 fours. Yes. Okay. So let's do the sixth one, which is your last one of this bit. Sixth bit. The Queen of Diamonds. So the Queen in diamonds, you will be having how much? You will be having only 13. Out of this, only one is your Queen. Okay. As I have discussed over here earlier. Okay. So so the required number of events are how many? 21. So the required probability comes out to be 1 by 50. So let's look at the next bit. Okay, let's read this one here. 5 hearts are there. You're having 5 different hearts. The first one is your hen, a jack, a queen, a king, and a ace of diamonds. Okay, all these are well shuffled with their face downwards. Okay, very good. So one is only. Okay, the first bit is what is the probability that that is a queen. Okay, so from this data, I can get the total sample of element n of s is equals to your 5. This is your total number of outcomes. Total outcome. Right? So the next thing is your required event. What is the required event? The probability of getting a queen. Okay, queen, the number of queens are only 1. Okay, are only 1 from this set here, right? You have only a single queen from this, right? So from this set. So the probability of n of e is, that is your favorable events by total sample events, that is 1 by 5 is your required answer. Hope this is also clear to everyone. Let's look at the second bit. Yeah, if you look at the second bit, okay, you have this as your n of s. N of s is how much? Now read this one. If a queen is selected and put aside without replacement, remember this. What is the probability that the second card selected is a bit? Okay, an ace. So let me write it here. A bit. A bit is your an ace. So from this set, you are having a ace, right? So n of s, the n of e, which is your favorable outcome is 1. Okay, 1 is an ace. So this is clear to everyone. Okay, so the required probability is your n of e by n of s, isn't it? Now here n of s is reduced. Why it is reduced? N of s is what? 4. How do I have this one? Because 5 minus 1. Queen is removed out here, right? Queen is removed. If queen is removed, that if this is your queen, so the left out is how much? 4. So this is your n of s. Hope this is clear to everyone, right? So let us look at the next one. That's your bit. A queen. As a queen is already removed, we are left with only a 10, a jack, a king, and a ace. So n of s is what? You have a 10, you have a jack, you have a king, you have an ace. But the requirement here is a queen. So n of s doesn't have a queen. That means n of s is 0. So therefore the probability of this occurrence of this event is 0 by 4. That is 0 is your required answer. Hope this is also clear to everyone. Okay, let us look at the next sum here, which is your 8 to 1. Okay, this is your 8. What is it? 8 to 1. Okay. If you read the question, you have 12 defective hens here are accidentally mixed with this many good ones, right? So listen, how many are the defective hens given? This is equal to 12, isn't it? The next is good And how many are those? This is 132, right? Now you have mixed them out. So if you are mixing it out, you are having a total ends of 144, right? So this is your N of S, overall sample elements. Hope this is clear, right? Now, what he is saying is, one N or article is removed out of the random from this lot. Determine the probability that it is taken out one is a good one. Okay, so the probability of a good N, a good N is what? So what are the number of good you are having? It's 142, and the overall is how much? 144. If you are dividing this, the answer comes out to be 11 by 12 as your answer. The answer comes out to be 11 by 12 as next one here. Now, if you look at this, a lot of 20 bulbs you are having, out of which these are defective. Okay, so let us remove the overall bulbs here. Okay, so let me write this data, number of defective bulbs. How many? 4. So number of non-defective. These are your good bulbs. Is how much? 20 minus 4. So if you do this, the resultant is 15. Hope this is clear to everyone, right? Okay. So let's look at this one. Suppose the bulb selected in a previous. Okay, what is the probability? Okay, let me remove this one first. What is the probability that the bulb is a defective bulb? Okay. So probability of a defective bulb is how much? Is the required number of sample elements of V by N of S, as I said already. Now here in this scenario, the number of defective are how many? 4. Overall this sample is how much? 20. Okay, if you divide this, you are having 5 as your answer. Hope this is clear. Now the next sentence, what is saying? Suppose the bulb selected in the previous case is not a defective, it's a good one, and it is not replaced. Okay, now the bulbs selected ran at random from the rest. What is the probability that the bulb is not defective? Now, probability bulb that it is not defective. Okay, so if you look at this one here, now what is this defective, non-defective are 16 here, and he says that and he says that this is not a defective, means you have removed 1 out of here. So 16 minus 1 is how much? 15. So substituting here 15. Overall is how much? 20. Hope this is clear. Okay. Overall is not 20 as you have removed 1 out of here. So you need to remove 1 from the overall also. So this becomes has to be 19. Hope this is clear to everyone, right? Let's look at the next one here. Now, what does this say? A box has 90 discs, numbered from 1 to 90. If one disc is selected at random from this box, find the probability. Okay, now the first bit. Let me do the first bit. As you can see here, the N of S is how much? N of S is your sample elements, or sample elements is 90. Hope this is clear to everyone, right? So let's look at the next one. The first one is a 2-digit number. So the N of E, the required favorable outcome is 2-digit number. So it is from 10, 11 and so on up to 90, isn't it? So the number of these are like that. How many? If you are having common sense, you remove single digit numbers. So the resultant is how much? Only 81. So this is clear to everyone, right? So n of is this one. So the required probability of this one is 81 by 90. Right? If you solve this one, you are having with 9 by 10. If you solve this, you'll have 0.9. So this is also clear, alright? So because this is 9, but this is 9. Okay. So let's look at the second bit. A perfect square number. This is second bit. N of E. What is your requirement? It is a perfect square number. So you are having what? One square number, right? So you have 2 square, you have 4 square, right? So you have 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, and 9 square, right? So if you look at this, 9 square is how much? 81, and the next number square is how much? 100. So the requirement is only up to 9 square only. Okay. So here this comes out to be n of e is equivalent to what? Only 9. So the probability of this is what? 9 by 90. If you are dividing this to 9 1 9 10, right? So this is your answer. So let's look at the third part here. A number which is divisible by 5. So n of e is what? Number divisible by 5. So in the given set over here, what are the multiples of 5? You have 5, you have 10, you have 15, you have 20, you have 25, and so forth, up to 9. So this is clear. So if you look at like this, you are having 18 such numbers. So the required probability of this one is also what? It is 18 by 90. If you divide this in the 18 table, 8 1 by 5 is the required answer. Hope this is also clear to everyone. Right? Good. So let's look at the next one here. Suppose you drop it dice at random on a triangle region as shown in the figure. Okay, so this is what the probability that it will land inside the circle with diameter. Okay, right, good. So let us see this one. What will be the required probability? The required probability is something. The requirement is the die should fall inside this circle. So we should look at area of the circle, right? So we should be looking at area of the circle by what is the total area for landing, that is total area, that is your rectangle. Hope this is clear to everyone. So let us solve this one simultaneously. Area of a circle, you know that pi is square. Hopefully everyone knows it out. Alright. Hopefully everyone knows it out. Alright. And total area for landing. Right. Area of this one is what? Area of the triangle is L into B. Okay, so let's say that into d square is r square by 2. I can write r square by 2, right? Then I'm saying that r, I have this one r square, right? By first d square is 1 square. Directly I can write it out, right? Area of a circle, right? So this is clear to everyone. This is your area of a circle. I wrote this as pi r square. Okay, L into B. So substitute like this, and L into B is L is your how much? It's B, and so this is clear to everyone, right? So this divides out directly 11 times, hopefully, right? 2 1s are 11 times, so you're left with what more over here. So this is what? 11 by 7 is 1 by 2 by. So this is clear to everyone, right? Hope this is clear to everyone. There's no doubt about it. So let's just do this. So when I'm solving this 2 out, I'm just writing the denominator thing here, 14 into 6, right? So this comes out to be 11 by what of 84. So this is your required answer. So this is the probability that the die enters into this circle here. All this is clear. So this probability is how much? Probability of 11 by 84. So this is clear. Let's look at the next one here. So this is easy only. Let's see. A lot consists of how many is my number of hens. So let me write here total number of hens. Total number of hens, that is your n of s, is equivalent to 144. Hope this is clear, right? So let's look at the first one now. So wait, you need to read the next one, right? Out of which 20 are defective and others are good. So number of defective hens. Number of defective are how many? 20. Then number of non-defective are how many? 144 minus 20. Then it comes out to be 120. Hope this is also clear to everyone, right? So let us do the first one. The shopkeeper draws what? The shopkeeper draws one of it and at random and gives it to Shudha. Gives it to Shudha. What is the probability that she will buy it and she will not buy it? Okay. So the probability is something like this. Okay. If she gets a good pen, if Shudha gets a good pen, Shudha gets a good pen, right? And the other situation is if Shudha gets a defective pen, a defective pen, right? So let us see this is scenarios now. Now probability of buying, probability of buying if it's a good pen, right? Only you wait for me to buy, okay, is equals to your n of e. What would be your n of e? This should be your good, means non-defective, right? The overall sum is how much? 140. Here, probability of not buying, probability of not buying it if it becomes a defective. This is 20 by 144. So this is also clear, right? So when we divide this one, the probability of that one is 31 by 36. The probability of this one is 5 by 36. Hope this is clear to everyone, right? Let's look at the next one. Okay, I think it's a lengthy sum, but eventually we need to do it. We have more options, right? So let's see here. A die is rolled simultaneously and counts are added. Okay, first one is that you need to complete this table here. Okay. The second one is therefore each of them has a probability of 1 by 11. Do you agree with your answer or not? Okay. Okay, let us look at this one data first clearly. Okay. Now sum of two dice. If you are looking at this one here, it is an event. The event is what? Event is sum of two dice. Two dice. Okay, what would be the sum? See, as a single die is having number 1, and on the other die the least number is how much? 1. If you add this sum is how much? 2. Similarly, you may have a probability of 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Hope this is clear to everyone, right? So let us look over here the favorable outcomes. The favorable outcomes, I'm taking it as n of e. You need to remember this is your favorable outcomes. Okay, this number, both the dice should be having 1 and 1, and both the dice should be having these two numbers, isn't it? Similarly, for this, I need 1, 3 and 3, 1. Hope this is clear. And similarly, what number to come out? Hope this is also clear. Right? Good. Yeah, good. And to get this number, the probability comes out to be 1, 4, also 4, 1. Right? And similarly, 2, 3 and 3, 2. Hope this is also clear to everyone. Right? To get a number 6, you should be having what? 1, 5 or 5, 1. And similarly, you should be having 3, 3. Similarly, you should be having 4, 2 and 2, 4. Hope this is clear to everyone, right? To get a number 7, I should have 1, 6 on both the dice. Also 6, 1 can be written and 2, 5 can be written. Also 5, 2 can be written and 3, 4 and 4, 3. Hope this is clear to everyone, right? Good. To get a number 8, I should get 2, 6, also 6, 2, and also I should be getting 3, 5 and 5, 3 and 4, 4. Hope this is clear, right? And in the next, you should be having what 9. To get 9, I should get 3, 6 or 6, 3 or 4, 5 or 5, 4 or eventually this only, right? Yes. And in the next one, you should get what n 4, 6, 6, 4 and also 5, 5. So this is clear to all. And in this one, 5, 6 and 6, 5, and at last this is 6, 6. Okay, so let us write this number here. Okay, so let me write this one here. The number is how many? One option you are getting. In this you are having only 2. In this you are having 3. This you are having 4. In this one you are having 5. And in this you are having 6. This right again 5 only. In this 1, 2, 3, 4, and in this you are having 3. In this you are having 2, and in this at last 1. Alright. So let us look at the probabilities. He is asking us to remove the probabilities. He is asking us to fill up all this. If you look at this part, right? So this is your probability P of T. Alright. So let us look at this. The overall number, if you are looking at the overall number, n of s is what is your 6 into 6, because each die is having 6 numbers on it. So the overall resultant of n of s is how much? It's your 36, right? So the probability is 1 by 36 of this number getting this sum of this number on both the dice, right? The probability of getting sum of these numbers on both the dice is this much, and similarly this is your this much, and this is your 2 here, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, again 5 by 36, again 4 by 36, and 3 by 36, 2 by 36, and 1 by 36. So these are the required probabilities, and this is your required table. Hope this is clear. So let us look at the 12th one here. What does he say? For this 12th sum, this solution is here only written. Okay, from the above table, from the table, the argument is wrong. I can say directly that the argument. You can see your textbooks. I have not here to stamp the whole question here. Okay, is wrong because the sum of 2, 3, 4 and so on up to 12 have what do have? They have different number of favorable outcomes. Moreover, the total outcomes are 12. Moreover, total outcomes. Total outcomes are 36. Therefore, the probability of getting 1 by 11 is not equal. Hence, it is wrong. Clear? So let's look at the 14th one here directly. Now, a game consists of tossing a coin. So whenever you are tossing 1 rupee, you will be having either heads or you will be having either tails, isn't it? Okay, good. Now you are having here 1 rupee coin. You are doing it 3 times, and okay, and noting its outcome each time. Dikshita wins if all the horses give the same result. Means all the three should be having either heads or all the three should be having either tails. Okay. As written here, three heads or three heads and loses otherwise. Okay. Calculate the probability that she will lose the game he is asking here. Okay. Okay, then let us look at this one. This is some, let me write n of s. N of s is nothing but coin is tossed. Coin tossed to the power of n times. Okay. So it is how many times? 2 to the power of 3. If you look over here is how many times? 3. Right? 2 to the power of 3. So the result of this one is 8. So n of s is how much? 8. So let us look at the required events. So what would be the required events? So when I'm tossing a coin, I may get all the tails. Also, I may get all the heads, isn't it? Also, I may get a tails head. Also, I may get this one. Also, this one, isn't it? And also I may get this one, and also I may get this one, also I may get this one. Hope this is clear. So if you look at this, 1, 2, 3, 4, 5, 6, 7, 8. So n of 8. So as you were saying, this is your this is your n of s. Right? N of s is your 8. So the 8 is always possible place. Okay. Now the required event. The required event is losing the game. Except these two, if you get any of this, you will lose the game. That is how many times are there? 1, 2, 3, 4, 5, and 6. So n of is a 6. Therefore, the probability of E, that is probability of losing the game. Probability of losing the game. What is this? This is n of E by n of S. So n of A is how much? 6 by 8. So if you divide this, half of that, half of this is a 3 by 4 as your required answer. Hope this is clear to everyone, right? Hope there's no doubt at all. Let's go to the next one now. Okay, this is a different scenario. We need to see it all the different scenarios. A die is thrown twice. Okay, a die is thrown twice. So let me write n of s here. N of s is 2 to the power of n as it is drawn twice. Oh, sorry, it's not 2 to the power of n, it is 6 to the power of n as you're having 6 different sides. Okay. So 6 to the power of 2, that is 6 squared is how much? The answer is 30, right? This is your n of s. Okay, so let us look at the next one. 5 will not come up either the time. There shouldn't be any in the required series. Okay, so let us write all the possibilities what we can get here, right? So the possibilities what I can get here is see, I may get 1, 2. So this is the technique I use here. 5 and 6 is your I number 1 and this is your dice number 2. 4, 5 and 6. See, if I look at this, I can write this as 1, 6. If I look at this, I can write this as 2, 6. If I look at this, I can write this as 3, 6. Okay, or else I can write this, I can write 2, 1. I can get 3, 1. Similarly, I can get 4, 1. Similarly, I can get 5, 1. Similarly, I can get 6, 1. In the next, I can get 6, 2. Next, I can get 6, 3. Next, I can get 6, 4. Next, I can get 6, 5. The next I can get 6, 6. Similarly, here also I can get 5, 6. Here I will get 4, 6. Here I will get 3, 6. Here we will get 2, 6. And here we will get 1, 6. Similarly, here we will get 5, 4, 5, okay, 1, 5. Sorry, 1, 5. Okay, here I can get 1, 4. Here I'll write 1, 3. Here I'll write 1, right? Here I can write 2, 2. Here I'll write 2, 3, 2, 4, 2, 5. These are the required possibilities when you are throwing a 2 dice. So this is clear to everyone, right? you're having any doubt, let us look at the first one. The first bit is, will E5 should not come. Should not. Right? If you look at this one here, I need to remove 1, 2, 3, 4, 5 and 6, 7, 8, 9, 10, 11, 12 numbers out of that. That is 11 numbers out of that, right? So 11 numbers if I am removing from 36. See this, what is this? N of E shouldn't come here. 36 minus 11, that is your 25. So therefore the required probability is how much? 25 by 11. So this is clear to you, alright? So similarly, let us look at the second bit. I will come at least once. Okay, at least once. So N of E, what? At least once. That is, look at this size now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and one more is here 11. So N of E became here 11. So the required probability of this one comes as 11 by how much? Okay, so okay, this is here, this one 11, this is here 36. I think I wrote that wrong. This is here 36. Okay? 11 by 36 is your required answer. With this